Alright, now we're going to take a look at graphing quadratics in intercept form. So in intercept form, y equals a times x minus p, x minus q. And intercept form really gives us the x-intercepts on our graph. So we find our x-intercepts by taking the opposite of p and the opposite of the q. Because if I were to plug p into this equation, p minus p would give me 0, and anything times 0 would equal 0. And if you remember, an x-intercept is where y equals 0. So really, what we need to recall and remember is that in intercept form, the x-intercepts are always going to be at the opposites of p and q. So if we look at my example here, I have the following equation. I have y equals negative 2 times x minus 1 times x minus 3. So right off the bat, I should be able to find my x-intercepts. I'm going to have one at 1, 0, and I'm going to have one at 3, 0. So if I plot those 2 points, 1, 0, and 3, 0, I should have 2 points starting out on my graph. Now really, one of the biggest ideas with being able to graph intercept form comes from the symmetry of quadratic functions. So because quadratic functions are symmetrical, I know the vertex has to fall somewhere on the line that's in the middle between these 2 points. Well, the line, the axis of symmetry, that falls between those 2 points is currently at 2. So if I want to find my vertex, it's going to happen when x is 2. So all I have to do to find the vertex is plug 2 in for my x values and solve for the y value. So for instance, if I take y equals negative 2 and I plug 2 in for the x and 2 in for the other x, now I just need to solve for what the y is. So y equals negative 2 times, well, 2 minus 1, that's just 1. And then 2 minus 3 is a negative 1. And then if I multiply this all out, negative 2 times 1 is negative 2. Negative 2 times 1 is a positive 2. So when I plug in 2, I get 2 out. And once again, this is going to be where the vertex is. So if I go over 2 on my graph and up 2, that is where the vertex will be. And then lastly, if you need 5 points to be able to graph the function, you just do the same thing. You plug in a value you haven't used. So we haven't used 0 yet. There's no points on 0. And then we plug that value into the function and solve for our 4th point. So if I plug 0 into this function, well, 0 minus 1 is just negative 1. 0 minus negative 3 is a negative 3. And then once again, I just need to multiply these. So negative 2 times a negative 1 is a positive 2. And then positive 2 times a negative 3 is a negative 6. So notice that when I plug in a 0, I'm at negative 6. So negative 1, negative 2, 3, 4, 5, and 6. And then once again, using that symmetrical idea, I should have another point that mirrors it on the other side. And the graph should curve down like this.